seems a great honour that someone's left their Christmas cards for us. So, it gives me great pleasure to introduce our third speaker of today, who is representing the world of museum collections. I first got to know Matt Kimberley when he worked at the Bodleian as the John Clay Sanskrit librarian. And he said at lunch to me today, it's very strange. It's the first time he's been at a conference where he's not been talking about the Clay Sanskrit project. When I got to know him then, even at that stage in his career, it was obvious that he had a particular interest in and talent for public engagement. So it's no surprise to me that he is now working at the Science Museum on an exhibition project for 2017, which will be highlighting the important contributions that India has had to make in the world of science and technology. So I look forward to hearing how it's all shaping up.
Thank you very much. It's very nice to be here again. This is my first time at Nakira in 3 years, I think it was the last time I was speaking. So thank you very much for accommodating me in the schedule, what was actually very last minute as well. So thanks to Gillian and Joshua for making sure I had the time to speak today. I was very keen to actually come and speak about the exhibition to this audience. Also, I'd like to thank the Nehru Centre, the Indian Council for Cultural Relations and the High Commission, not just for today, but for the enormous amount of work they've been doing with the Science Museum to make the exhibition possible. Along with, in India, the Ministry of Culture, the Ministry of External Affairs, the Department of Science and Technology. As you may be able to gather, we had a bit of a whirlwind tour in India just recently, meeting with a lot of departments and gaining support for what we're attempting to do next year. So we're incredibly pleased with the amount of cooperation we've had across the board. So today I'm going to speak about Science and Technology of India exhibition that we're preparing, and I thought in particular I'd try and relate the content to today's theme of India Beyond Borders. Don't worry, the presentation won't be sort of forcefully shoehorned in that direction. We genuinely are looking at the idea of defining and transcending borders within and beyond India as a recurrent theme in the exhibition content. So, you wouldn't believe I spent 2 years working in digital and it won't move at all. A season at the Science Museum running from September 2017 to March 2018. I'll just step aside again. This is the first time the Science Museum will ever have done a themed season as part of its temporary exhibition programme. And as well as the two exhibitions, one of which I'll be speaking about today, there's also going to be a cultural events programme running along throughout. I don't know how well anyone knows the Science Museum here who have spent much time there. One of the major national museums in London, it attracts over 3 million visitors a year. So as you can imagine, being a free temporary exhibition running for 6 months, we're hoping to reach an incredibly large audience. And that, of course, is an international audience, given the number of tourist visitors we get to the museum. Oh, no. So, for instance, things that the Science Museum run includes Science Late. It's one of a few museums that do that. The final Wednesday of each month, the museum opens up again in the evening for adults-only audience, though nothing risque, until 10:30 in the evening, and all sorts of activities are put on. It's incredibly interactive, very fun. I work these occasionally. I think we attracted 4,000 visitors just on one Wednesday night recently. A lot of high-profile speakers come along to these, so there will be one dedicated specifically to science and technology in India in the late programme. Hopefully also Science Nights, which is geared more towards school groups. And we'll probably have some kind of lecture series going along and performance arts related to it as well. So this really is going all out in a way that's very new for the Science Museum, and it's real honour to be doing that over over the subject of India. So the first of the exhibitions which forms the season I'll make only a brief mention of, since I'm not actually involved with it myself and therefore don't know a huge amount about it. But that's on India and photography. It will be showing images, original prints, which reflect the role that Indian photographers have played in the development of the medium, both technically and artistically, since as early as the 1850s, which came as a surprise to me, and at the same time the role that India has played as a place and as a people in the work of international photographers such as Mary Bourke-White. The 1850s date particularly surprised me because photography itself, well, the daguerreotypes come about in the 1820s, so it's an incredibly significant thing that India was so involved in a pioneering technology at that time. That's all right. I once did a session which was entirely dependent upon computers with a large school group, which Gillian will remember, where I got there to find out that the college didn't have any internet connection available in the room or a projector screen on which to do the presentation, and the entire thing had to be done on the fly. Old school, as we call it now. So by comparison, this is a breeze. Yes, there we go. Thank you. Where were we? So, Science and Technology of India. Which I should point out is still a provisional working title. We are going to come up with something slightly more interesting, exciting than that by the time the exhibition launches. Is being curated by my colleague Mr. Ratan Vaswani, and will showcase some of the highlights of South Asian contributions to science and technology over the past 5,000 years. Of course, 5 millennia, an entire subcontinent and all disciplines of science being the modest aspiration that it is for an exhibition, we'll only be covering the real highlight moments that we can select out of all of that in the scope of about 70 objects. It keeps growing, so I'm saying at least 70 objects for now. Remind me later. I wouldn't want to be distracted with that now. So the intent is very much to capture just some of the most important moments in scientific thinking, mathematical thinking, engineering, which has been undertaken by South Asians and by people working in South Asia. The aim is to highlight three key messages that we want to have the audiences take away about science in South Asia. The first being that from the ancient past to the present day, South Asia has an unbroken tradition of science and technology. This, I think, we've really managed to capture in the full spread of objects that we're including, which start in 2,500 BC, as you'll see later on. The South Asian ways of doing science were sometimes different from Western ways, but had a shared basis in logic and evidence, a very important point for us to communicate in this. And finally, that science has been valued in South Asia, both as a way of understanding the world and for creating a better society. And in that regard, particularly, we'll be looking at many of the important scientific and technological developments achieved in India in the 20th century with regard to things like medicine and agriculture to support its own society. Rather than do this in a boring chronological fashion as well, which sometimes has its merits, but in the case of an object-based museum exhibition wouldn't be the most riveting, we've gone for themes of observation, calculation and innovation by which to tell this story. But at the start of the exhibition, visitors will first encounter a statue of the Buddha, of the kind seen here, performing what's known as the Bhumisparsha mudra, or earth-touching gesture. It's one of the most common kinds found in Buddhist statue art, symbolising the episode in his life when the demon Mara attempted to lead the Buddha astray from his pursuit of enlightenment through deception. Touching the ground, the Buddha called upon the earth itself to bear witness to his commitment to the path of reason and wisdom. So we felt that this tale and this action itself gives testament to an idea that extends, well, it's found throughout Buddhist philosophy, but extends beyond it and can be found throughout India's intellectual tradition, that the pursuit of an understanding of the world, both seen and unseen, through the use of reason, observation, and experience or experiment. That, we hope, will set the tone for what follows through the next 3 main zones. Each will be divided into 4 main topics, so I'll start off by talking about the observation zone, which is divided into sky, nature, energy, and territory. And as you can see, we'll be using a mixture of terms in native Indian languages to describe these main areas. So, to begin, sky, or Akash, we'll examine the tradition of observational astronomy, which dates back to really the earliest stages of the textual and material records that we have for India. It will look at accounts of how the known universe was ordered, and in particular, we will be featuring a Jain cosmographical work, a Jambudvipa Pata, but then following that all the way through to modern contributions to astronomy. So, for instance, in the early 20th century, astronomers working at Kodaikanal Observatory under the direction at that time of John Evershed and then Thomas Royd made huge achievements in solar physics, including new discoveries about the sun's chemical composition and the nature of solar flares. None of that would have been possible were it not for an observatory placed as high as the Himalaya allow you to get and beyond all of the kind of atmospheric interference that you would have had problems with in European observatories. That is carrying on to this day. The observatory at Hanle in Ladakh gives its situation high in the mountains, apparently the 2nd highest optical telescope in the world, as a means by which to continue to contribute to breakthroughs in observational astronomy. Nature, for which we're taking the term Prakriti, people may wish to make some suggestions about the terms as well. Obviously, it's always a bit difficult to, in the rich vocabularies that Indian languages give us, to settle on the one that captures it best. But nature will look at the long tradition of examining and learning from the natural world. As early as the Vedas, there was a systematic study of plants, soils, and seasonal changes. This was motivated not only by agricultural needs, but by medicinal ones. And it was courtesy of these great insights that botany informed medicine at an early point in Indian intellectual history. In similar ecological themes, it would be remiss of us not to mention the Ashokan Edict, which first set out an obligation on people to take care of certain kinds of animal and plants, and where they are not to be found, to import them into an area and care for them, which I think may well constitute the world's first environmental state policy. If anyone knows to the contrary, I'd love to hear it, but we think it may well be India that really makes that first important leap. Later on, in the court of Emperor Akbar during the 16th century, another theme emerged. Akbar commissioned court painters to actually go out across the country and make detailed illustrations of flora and fauna in their natural habitat, which I think is particularly interesting. Rather than a detached scientific drawing of these animals, they were there in the environment in which you would find them, which gave a real sense to an environmental inclusivity in Akbar's perception of the world at that time, but also launched an active process of animal conservation. So we of course know of African elephants and Indian elephants. What's now referred to as the Indian elephant was once found right across Asia in really quite a large geographical spread. However, as is so often the case in human history, they were hunted and hunted and hunted until their numbers dwindled to near few, until Akbar actually insisted that special reserves be created, the intention being to rear elephants as war elephants, but by doing so, to actually ensure that there was a sustained population of them. The reason we still have elephants there today. I think really quite a staggering story from the 15th century there on environmental awareness. But it isn't just an ancient or medieval story we want to tell, and throughout the exhibition we'll be capturing the active role that India plays in science and technology through to modern times. So, well, some of the instruments which I'm pleased to say we've just had confirmed as being available to loan for the exhibition will be from J.C. Bose, one of the great scientists of India, and indeed one of the greatest scientists in the world of his time. A true polymath, working in Calcutta, who, along with hanging out with Tagore and discussing philosophy and collecting fine artworks. Also happened to invent two machines, a compound lever crescograph and an oscillating plate phytograph. I'm sure you're all familiar with, I won't explain those. Was able to actually measure minute details of plant growth and details of plant physiological processes. And this is late 19th century that he's achieving this work. And of course we all know about Marconi, who gave us the birth of wireless telegraphy and radio technology, or not. Actually, again, it was J.C. Bose who did the pioneering work in this area, invented the first prototype for picking up radio waves, did a public test of this in Calcutta in the early mid-1890s, but decided that doing it for science was reason enough in itself. That was the contribution. What was important was to do the research, to build the technology, and to share with the world. Not being therefore an enthusiast of getting into the patent law battles, Marconi now receives all the great credit for this great invention, and India once again has been somewhat sidelined in the history of science, despite being the place from which these achievements first came. So, having met with the J.C. Bose Trust and visited the museum there, the Acharya Babam Centre, we're very pleased to have arranged to have these objects, the original objects built by Bose, included in the exhibition. Energy, Urja, is going to be the area in which we look at some of the more applied and experimental physics. So, again, this story takes place largely in the late 19th and early 20th century. Bose being an important part of this with his Galena semiconductors, which allowed wireless communications. But a number of other key figures also came to prominence at that time, all as part of what's often referred to as the Bengal Renaissance, when there was a real flourishing of philosophy, art, literature, and scientific research centered around Calcutta. There are certain household names in physics, even for those of us that aren't inducted into the world of physical research. Einstein, we all know Einstein, Schrödinger and his cats. These kinds of figures, who are the founding fathers of quantum mechanics. Again, that's only one part of the story, and very much the European part of the story. S.M. Bose, through his correspondence and developing collaboration with Albert Einstein, made the major founding contributions to statistical understandings of quantum mechanics, and I believe some areas of solid state physics. At the same time, around that same time, C.V. Raman was working not far away in the same city, developing areas of both acoustic and optical physics. He developed a machine called a spectrometer, which demonstrated how the passing of light through a suspended liquid could shed light not only on its chemical composition, but also on the quantum nature of light itself. This earned him a Nobel Prize in 1930 and made him the first Nobel laureate in the sciences outside of Europe to receive that honour, and one of very few since actually. But like everyone in the Bengal Renaissance, he wasn't content with just making major Nobel Prize winning contributions in one area, and also studied the acoustic mechanical properties of instruments. So Veena, classical Indian stringed instrument, he studied sound production from. We'll also be including a Veena in there as well, which is very nice to have. And again, as part of the exciting trip we've just had, we met with the Indian Association for the Cultivation of Science, who have Raman's original spectrometer still there, which was set up and shown to us in as close to working condition as could be expected after 86 years, and have indeed agreed that, all going well, we can loan this for the exhibition too. So one of the most exciting things to include, partly because of the importance of Raman spectrometry. Has anyone heard of Raman spectrometry, by the way? Yes. Possibly one or two people may have, and particularly at the Bodleian. It's one of the most important techniques used in the sciences now. It applies to just about every branch of science. Chemists particularly use it. It's used in forensics, and of course in the analysis of pigments, which you might, for instance, find in manuscripts. So we're very pleased to actually have some manuscript as part of the exhibition as well. As Indologists know, while there's ample textual history for India, the material cultural artefacts are somewhat more scant very often. So we will be using a lot of textual material, but part of our hope is to include something which has undergone a Raman spectroscopic analysis, which we can also display alongside it. I'll move outside now from my comfort zone of experimental physics onto the next area, territory, or Zamin. In this, we're going to focus almost exclusively on the work of the Survey of India. So what we did find a bit of a surprise while we were out there meeting with the Surveyor General was that, in fact, next year is the 250th anniversary of the Survey of India as an institution. Not only is that a venerable old age for any institution, but as far as we're aware, it makes it the oldest continuous scientific research institution in the world. So the fact that they have agreed to loan us 3 objects for this exhibition during their own very august celebrations is a huge honour. The endeavour of the Survey of India wasn't purely, although of course originally motivated by the British need to assess what it possessed in the reaches of its empire, but also as part of a wider cartographic endeavour across the world. It resulted in accurately measuring the heights of the upmost Himalayan peaks, including Everest and K2. Though I didn't realise George Everest never actually saw Everest, let alone go there. Just named in his honour. But also made it possible to measure the greatest extent that had ever been managed at that time of an arc of longitude, thereby making it possible to calculate the precise curvature of the Earth. This was a huge contribution to cartography, to geography, to geophysics, navigation, the development of surveying instrumentation. When it started so although the Survey of India was founded 250 years ago, this actual surveying by triangulation began in earnest in 1802, with the ambition of being done in about 5 years, which is a bit like us saying that we're going to capture all of the history of Indian science in 70 objects. 70 years later, they had finally managed to triangulate and accurately map the topography of India, which I think is a beautiful tribute to just what the scale is when you deal with the study of India. You set out thinking you'll be done in 5 years, and 70 years later, you're still plugging away, hoping you'll get that final addition done. For this, we'll be borrowing the index to the Great Trigonometrical Survey from the Royal Geographical Society, and as I mentioned, a few objects from the Survey of India itself in Dehradun. This will include the Great Theodolite, designed by William Carey for William Lambton, first Surveyor General of India, which stands at just over 6 foot high, yay big. In museum terms, a logistical nightmare for transportation, but we've got a year to get ready for that. Other important instrumentation that was used to do this includes what's called a Ramsden's 100-foot chain, which is very important for getting accurate baseline measurements to do these triangulations. We won't be borrowing Jesse Ramsden's original 100-foot chain from them as well. And George Everest's compensation bar, which was used to assist in making sure that effects in materials by temperature variation hadn't in any way created inaccuracies in the measures. So all in all, really some very significant objects to be able to include, and I'll just, there we go, that's both the index there to the GTS and the Great Theodolite. So moving on from observation, second zone is that of calculation, covering what we're calling zero, but we'll look at the idea of pure and applied maths very broadly, water engineering, space engineering, and data. One of the major contributions India makes to science and technology today, of course, being in the IT industry. So, as I think most people in here will know, the number symbols that we use today and widely across the world, and indeed our decimal place system too, all come from India. It was Indian mathematicians who at the very earliest stages saw numbers not just as tools for counting and accounting, or indeed just for measuring, but also as abstract entities in and of themselves. One of the most important objects, indeed I think we feel it's the star object of the exhibition, is the Bookshali manuscript from the Bodleian. So thank you very much for that. This is a real honour to be able to include. It's one of, if not the most significant manuscript in history of mathematics, insofar as being the earliest written account of a zero in numerical workings, currently dated between the 8th and 12th century CE, though Camillo or Gillian may be best authorities on that. Yes, so there could be very exciting developments going on around this manuscript in the near future. We hope to be able to give a real date with some high degree of accuracy in the not too distant future. But as you can imagine, for a science museum, being able to show the first zero used in maths really is about as big an honour as it gets, particularly as we're just opening our mathematics gallery as well at the moment. Furthermore, we've also been in conversation with Cambridge University and the Wren Library at Trinity College, who hold the papers of Srinivasa Ramanujan, who some might be aware of as an Indian mathematician who came to Cambridge to study in the 1910s. To say he was ahead of his time would be an understatement. Mathematicians are still studying the work he did and trying to unravel some of the ideas that he had. It was extraordinary feats, recently put into biopic form in a film, which I don't know if anyone has seen, but it's very, very good. Some of the particularly important insights that Ramanujan gave us was a mathematical framework necessary for understanding black holes, not that anyone had even predicted they would exist yet when he did it. And also a lot of the mathematics in terms of infinite series, which has provided the foundations for modern digital encryption techniques. Again, at a time decades before computers had come along. This is how incredibly sophisticated his mathematics was and what foresight he had. So to be including some of his papers will also be a huge honour. I did say we were going for the full 5,000 years of material history for India, and this is where it really begins. We are, of course, borrowing from a number of esteemed institutions in India and across the UK, but the Science Museum itself has a fair number of very interesting objects in its own collection. When I started, my first job was to go through the collection on its catalogue and whittle down from 2,800 or so objects, which might make it into our 70-odd object exhibition. There was no doubt about this one. A set of stone chert weights made by the Indus Valley or Harappan civilization, the estimate being on these 2,500 to 3,000 BC. The Harappan accomplishments in engineering were unlike anything else at the time in the world, particularly with regard to water management. Their entire city planning really was built around conserving and using efficiently water. They would build incredible reservoirs that surrounded the city and captured rains. In some cases, I believe near Dolavira, divert a river in order to ensure that the water could come and fill their reservoirs. They had drainage and sewage systems which would not be seen again in their like until the Romans, including what appeared to be means by which to bring clean water into every domestic residence in a city and to take sewage out. To think of that level of democracy of access to a vital resource in a city in 3000 BC is really quite staggering. And it shows just what, of course, not being able to read the Indus Valley civilization script, we're still left in darkness as to a great deal about who they were and why they did what they did. But what we certainly can see from the archaeological evidence is what incredible civil engineers they was and what advanced mathematics and astronomy they must already have had to be able to achieve a lot of what they did. So to have these weights as a part of demonstrating just how much they had already made leaps and bounds in developments in measurement is, for me particularly, I feel one of the real highlights, which started in the 1960s and continuing to this day, ever growing. It launched its first Rohini sounding rocket in 1967, which is of the kind pictured here, with the intent of doing meteorological research. And as I said, one of the key messages we want to get across in the exhibition is the way in which in South Asia science and technology are being employed for the betterment of society as well. And the space program is one of the ways in which that is really truly well reflected in contemporary India, where the space program, as well as simply being the prestige for any country to have an active space program, is geared up towards undertaking meteorological research, which in turn supports agricultural research through its satellite technology. It supports rural education by being able to beam educational content into remote areas. It really does play a vital part of modern India, and we would be remiss not to include that in the exhibition. So we are hoping, in fact, to commission a model of an original Rohini sounding rocket as part of this. But when we're talking of boundaries and borders, India keeps pushing beyond even earthly borders and even our near terrestrial borders, and in 2013 launched the Mars Orbiter mission, which made India the first country to enter Mars orbit on its first attempt, which was news to me doing research behind this exhibition. Of course, there have been plenty of missions to Mars, but the US and Russia had quite a few near misses before they finally got there. India did it in the first attempt, so that really is an achievement to be proud of in space technologies. Oh, sorry, to just briefly talk about the final section in calculation data. India is of course a global leader in the IT industry, and especially for software, but that is by no means all that it has contributed, and in hardware it's had two really particularly important moments. It was the Indian-born and educated Ajay Bhatt working in the US, who in 1995 led a team at Intel who built the first USB device, the thing without which, well, where would we really be now? I mean, one of the most important parts of modern computing technology that's created that kind of ubiquitous sharing of data in the world today. But also, again, with reference to creating a better society and a fairer democracy, in 1988-89, India developed the electronic voting machine. Now manufactured by Bharat Electronics, but always done under the purview of the Electronic Commission of India and the Electronics Corporation of India, which has allowed it to make the democratic process as accessible as possible to its 1.3 billion people. The way in which the machine is designed also makes it possible to overcome issues of literacy and language diversity by combining both image and text. The things are amazing. They're about this long. They look like a keyboard with a button on each to register who you wish to cast your vote for. They also use a special indelible ink, also developed and manufactured in India, which they mark on your fingernail to get around issues of voter fraud. That lasts for the better part of a month. So we've met with the Electoral Commission, and of course, given the incredible seriousness of these machines and their use in India, we will not be borrowing one of those itself for reasons of security. However, we do hope to at least be able to show the casing of this and a lot of the ephemeral material and ancillary documents that they use, educational films, posters and the like. So again, it's a real honour to be the first place in the world outside of India that will be able to show exactly what they've accomplished in that development. So just to come on to the final zone now, innovation. It goes without saying that innovative thinking could be seen in all of South Asia's contribution to science and technology, and is an inherent part of the development of science and technology the world over. However, in this zone and in these particular areas, we think India has made exceptionally innovative contributions. So that's medicine, industry, transport, and communications. Given that India lacks a lot of the financial and technical resources that the Western healthcare systems do, resourcefulness on the part of Indian medical technologists has led to the development of these wonderful devices that really make you have a bit of an moment. Very low cost, highly heat retentive neonatal warming pouches. So this baby sleeping bag here is battery powered, lasting for up to 8 hours without needing to be recharged, and serves to all intents and purposes exactly like an incubator you would find in a hospital anywhere in the world. However, it does it for a matter of a few thousand rupees and isn't dependent upon a stable electrical supply, therefore circumventing any issues of a power cut, making it useful in rural areas. I mean, one of the terms that we will be exploring in the exhibition is jugaad, which we're still debating the best way to translate that. A common way is frugal innovation, innovating on a tight budget, which in the world of libraries, archives and museums, I think we all know very well. However, another, I think, good translation of the word in modern Hindi is hack, which particularly if you work in digital, not that idea of hacking, but this idea that you find a bespoke, innovative solution to a problem by circumventing the traditional ways of doing it, which is what hackathons, as we hear a lot about these days, are in the spirit of. Wootz still, I'm sure will be familiar to many. It's hard to date just how far back it goes. It seems to have originated in South India, to the best of our understanding, and very possibly in the early centuries of the Common Era, certainly in the first millennium. Tougher, more resilient and more flexible kind of still than anything anywhere else in the world up until the 19th century. And even then those advancements in steel came really through the study of existing wood steel material in Europe through chemical and metallurgical study in order to figure out exactly what this process was that they had discovered, also sometimes called Damascus steel, through which it was more popularized in Turkey and then in Europe. And the steel industry isn't just historic in this regard, but is still a thriving aspect of the Indian economy into the 20th century, and a key part of that idea of Swadeshi, or national self-reliance. The other aspect of industry which we want to talk about is the chemistry of dyeing and the textile industry, which has an equally long and prestigious history in India. And for that we'll be including examples of some of the dyes that have been used in different processes for fabric in India, as well as an example of dyed material swatches, which provide examples of the kind of material you might wish to purchase from India, used by traders under the East India Company. Before going on to communication, also just to speak briefly of transport. Of course, we all know that the Indian rail network is one of the world's most extensive. Although created initially by British engineers as a tool for military control and commercial exploitation, it actually enabled Indians to travel rapidly and communicate ideas across vast territories, and indeed to turn that power to one of their own advantage. Today, equally, three-wheel auto rickshaws are adapted from two-wheel scooters, providing economical, practically viable transport in congested low-speed driving environments that the subcontinent has to offer. I guess, although obviously anyone who's experienced getting through the traffic in an Indian city knows we're still not working at great speeds. Finally then, to talk about communication, first rail and telegraph and then radio and film were seized upon to coordinate political agitation and liberation from British rule in India. Indians not only embraced new media for political and other purposes, but also as part of technological research. I've already mentioned Bose's contributions in this area, but communication also had, as it does for anyone, anywhere in the world, a much more essential and everyday purpose about sharing knowledge among people. And so to this end, we also want to include a bioscope. So, although I believe these were actually originally invented in Italy, they were very quickly transported to India, where they became widespread technology. It's They almost each of them is unique. So let's say on average a box about this big, beautifully decorated, with a bulb inside and backing on which to project, and a hand crank with which to turn the film shown inside. And along the side, as you can partially see in this, were little viewing ports. And so a bioscope wala would move from village to village and town to town with his selection of film reels and play them to people. And for most people, this was their only way of seeing news and footage from outside their immediate environs. So an incredibly important technology in its vernacular applications. Also objects of real beauty, and the hope is to include an interactive one of these as part of the exhibition, particularly for parents and grandparents of South Asian origin. These will be a really familiar bit of technology. So the hope is that we can actually encourage some intergenerational dialogue as well, so that the children coming along to see this will actually be able to be told stories about first-hand experiences of what their families saw on these in their homes. So I said this would be about India Beyond Borders as much for our exhibition as for today's theme. And as I've mentioned throughout, I really hope we manage to capture, by just selecting even a few key scientists, what a global impact India has and has always had in the area of science and technology. And that likewise, India as a nation has always played host to scientists and technologists from the rest of the world and helped develop their work too. Finally, in a slightly more cerebral idea of borders, thinking about our borders themselves within the exhibition, although I've talked about these zones and these sections within them, this is not going to be a case of 12 strict disciplines broken up into 3 areas that the audience will be shepherded through by the design of the space. What we want to do is, partly by using the design of Jantar Mantar built into the actual physical shape of the space, create open room and lines of sight that mean whichever section of the exhibition you're in, you have a sense of the other areas of work that have been achieved simply by where you're looking. So, for instance, when it comes to the meeting of observation and innovation, we have descriptions in Ayurvedic texts of surgical tools which were based on observational design. Well, in the example here, it's a curlew forceps. So they developed a forceps to reflect its mouth to work more effectively in that kind of pinch. Similarly, there are ones designed on lions, for instance, that we'll include. I believe there's wolves as well we have in the collection. These are part of the Wellcome Trust collections that we hold at the Science Museum. Calculation and invention, I believe IT industry most well reflects, and there with the USB, and also which on technology, astrolabes will indeed feature. There will be an astrolabe, a fine Lahori craftsman astrolabe, which show the points where observational astronomy meet the practical calculations required for navigation and travel. So this really has only been a very brief overview of what we aspire to capture in this exhibition. The richness of Indian intellectual traditions is much too great and wide-ranging, I think, for us to exhibit in less than 100 objects in 6 months of display. Indeed, it would take thousands of objects and, frankly, thousands of years to do that. But our chief aim is to bring to the attention of an international audience, which the Science Museum attracts, a taste of India's limitless capacity for scientific imagination and insight. So I'd like to thank you for your time today.